simulate this. So here we see I have used an universal opamp that's there in this. In LT space. It needs a positive and negative voltage, a plus 10 volts and a minus 10 volts. So those I have generated here. And the input is a square wave. So the square wave I'm using here is minus 1, starts from minus 1, goes to 1. There's no delay. The rise and fall time are small, 0.1 microsecond, stays up for 10 microseconds, and the whole period is 20.2 microseconds. So the resistor I have put is 1 kilo ohm and the capacitor is 1 nanofarad. So if you think about the 1 over RC, which is our slope, that is 1 by 1 kilo, that is 10 to the power of 3 into 1 nano, that is 10 to the power of minus 9. So this is 10 to the power of 6. So that's a megavolt per second. I mean, it's not on for a long time, it's only on for 10 microseconds. So within one period we expect in that 10 microseconds into 10 to the power of 6 volt per second, the micro and 10 power 6 cancel, so I should get a change of around 10 volts. So this was slope. And this is what should happen in a period. So this is actually to a small t divided by RC, and this is the final value of that. How much would this change over a period is, or over the period when it is on, over the on time would be this. That's what we have done here. So it should change 10 volts from top to bottom, bottom to top. So this should be around 10 volts. Okay, so let's see what actually happens. So when we simulate it, the input that we expect is going from plus 1 to minus 1. And this is minus 10 volts, so that's way down there. That's plus 10 volts, that's way up here. So this makes sure that hopefully the amplifier is not limited by its supply and it's operating somewhere in the middle. It should be fine. So let's look at the output. So we see that initially there is some transient waveform, and after that it's what we expected. If we plot it as a function of input, then we can see that whenever the input is low, it's reversed, right? So it's going up, and whenever the input is high, it's going down. So we say, oh, okay, it's not exactly minus 5 and 5. What can I do to make it exactly minus 5 and 5? Something is getting stored here initially. Okay, another thing is I have been sneaky and I have sneaked in some extra things that you are not aware of. So this is right here. It's called spice directives. You can also put comments. Okay, so what would happen if I didn't have a spice directive? Okay, so now the voltage actually starts from 10 volts volts, and it never reaches 0. Why does this happen? Okay, let's see. Initial voltage is -1 when I release the whole simulation. I didn't say that this has to be some specific voltage. So when this is -1 volt, this node is also at -1 volt because the capacitor is open. Right? We started. Where do we start? So if this is a negative voltage, it's going into the minus terminal. So this is going to be a very positive voltage, and a very positive voltage. This amplifier with a supply of 10 volt can be is 10 volts. So it starts there, which means this capacitor charge starts by being charged to 11 volts, and then the rest of the time we are just going back and forth. So it's only going down to 1 volt because hey, we wanted to charge it up to 11 volts, and some of it it's some of it is wasted because once it reaches 10 volts it can't really ramp up anymore. Yeah, so this should have been, well, it is. So it's not able to use the fact that this could have charged more, so it gets clipped there. So this is an example of where a waveform gets clipped. So some of the ways you can encourage Spice to give you what you expect, or is to force nodes at some points. So that's what we have done. We have forced the output to 0. Oh, and I should say it is a Spice directive. Okay, so but the real question is, what about in the real circuit? How do we possibly know where we are starting, or how do we set any of this in a real circuit? That's a good question, right? So the other question is that if the frequency changes, I have said this now for a 20 microsecond period. If the period was something else, what if the period was 1 microsecond? What if the period was 100 microseconds? What would the output voltage look like, and how would I make that look like a triangular wave if that's what I wanted? So I have to actually change the slope. So what I'm saying is, if this period had changed to double of its value, then this voltage would have definitely gone and hit up to 10, and then that would have ramped down to -10. I mean, the period is increasing, so the time for which that it's available to rise up and down would change. What if I didn't want that? What if I wanted a ±5 volts, around ±5 volts all the time? What would I need to do uh, in terms of changing the value of either R or C? Uh, then how would I do that in the real world? So these are things to think about.